Imagine, if you will, the sun decides to wipe out all life on Earth. A chilling thought, isn't it? Yet it's not entirely out of the realm of possibility. Today, we're delving into the cosmic world of solar flares, massive eruptions of energy, light, and high-speed particles that the sun, our solar system's life-giving star, can unleash without warning. The sun, often seen as a constant, comforting presence in our sky, is in reality a volatile and unpredictable force. Its surface is a seething cauldron of plasma, and its magnetic fields are a tangled web that can snap, releasing the energy of 100 million hydrogen bombs in the blink of an eye. That's a solar flare. These solar flares have the potential to cause catastrophic damage, wiping out power grids, disrupting communication, and even posing a threat to life on Earth. So, what exactly happens if a solar flare engulfs Earth? Let's dive in. Solar flares, in essence, are enormous explosions on the sun's surface. Now imagine a hydrogen bomb, the most powerful weapon in our world. A solar flare can release energy equivalent to millions of those. That's right, millions. These flares are born from the sun's twisted magnetic fields. When these fields cross each other, they create a solar spot. As the pressure builds, they eventually erupt, releasing an intense burst of radiation into space. Think of it as a cosmic pressure cooker that's reached its boiling point. This radiation is composed of high-energy photons, including X-rays and ultraviolet light, along with charged particles. All of these zip through space at the speed of light, a staggering 186,000 miles per second. Now, to truly grasp the scale of these solar eruptions, let's consider this. A single solar flare can stretch up to 10 times the size of Earth. That's like stacking 10 Earths on top of each other, and even then, we're barely scratching the surface of the sun's colossal flare. But despite their size, solar flares are not always visible to the naked eye. They're like invisible cosmic giants, playing hide-and-seek with us from millions of miles away. It's only when they're particularly strong, and our planet's in the right spot, that we might catch a glimpse of their spectacular light show, painted across our planet's night sky. But don't let their beauty fool you. These celestial fireworks are anything but benign. They're packed with enough energy to wreak havoc on our modern world. From frying electronics to disrupting communication networks, the potential damage is extensive and far-reaching. So, if these flares are so powerful and potentially destructive, it begs the question, how does something so distant, so seemingly detached from our everyday life, become a threat? But how does a solar flare millions of miles away pose a threat to us here on Earth? The danger lies not in the flare itself, but in its after effects. Picture a time when the sun, our life-giving star, suddenly turns hostile. This isn't science fiction, but a stark reality we've faced in the past and could face again. In the late 19th century, telegraph systems worldwide went haywire. Sparks flew from telegraph machines, setting papers on fire, and operators could send messages even when the power was off. This bizarre event was due to a solar storm, known as the Carrington event, which hit Earth in 1859. Solar flares, colossal eruptions of energy from the sun's surface, send out a stream of charged particles called a coronal mass ejection. When these particles smash into Earth's magnetic field, they can cause a geomagnetic storm. The Carrington event was one such storm, the most powerful recorded in human history. But what happens when these invisible threats strike our technologically advanced world? We've already seen a glimpse of it. In 1989, a solar storm knocked out Quebec's power grid, leaving 6 million people without electricity for 9 hours. In 2003, another storm, nicknamed the Halloween storms, caused satellite disruptions and power outages across the globe. Yet, these incidents are just a small taste of what a truly colossal solar flare could do. Imagine a world where power grids collapse, satellites fail, and communication systems break down. We're talking about a global blackout, a technological Armageddon, if you will. The effects on our environment, too, could be devastating. Increased solar radiation could damage the ozone layer, leading to higher levels of harmful ultraviolet radiation reaching the Earth's surface. But it's not all doom and gloom. Understanding these solar threats is the first step towards protecting ourselves. Scientists are working tirelessly to predict these solar storms and develop technologies to shield us from their impacts. So, as we bask under the sun's warm glow, let's not forget the invisible threat it poses. For these incidents are mild compared to what could happen if a truly massive solar flare hits Earth. So, the million-dollar question, could a solar flare wipe out all life on Earth? No one can deny the power of our sun. It's a massive furnace, churning out energy at a scale that's hard to comprehend. But could one of its flares really bring about the end of days? The answer is layered, as it depends on a number of factors. The size and intensity of the flare, for instance, would be a key determinant. A small flare would likely be absorbed by Earth's magnetic field, causing little more than a spectacular light show. But a flare of colossal proportions could potentially overwhelm our planet's defenses, leading to catastrophic results. Moreover, Earth's protective measures, like our magnetic field and atmosphere, play a crucial role in shielding us from solar radiation. The strength and stability of these defenses would greatly influence the scale of the impact. While the odds are low, the possibility is real, and the consequences could be devastating. In the face of such a threat, what can we do to protect ourselves? You might wonder. The answer lies in ongoing research and innovative strategies. Scientists are hard at work developing advanced prediction models to forecast solar flares with better accuracy. This could give us precious time to take protective measures. Teams around the world are also investigating technologies to shield our satellites and power grids, the lifelines of our modern world. The aim is to make them resilient against these celestial firestorms. But these are just pieces of the puzzle. We need to foster a culture of curiosity and learning. Encourage each other to delve into the mysteries of our sun, to stay informed about the latest discoveries because, as the saying goes, forewarned is forearmed. Remember, knowledge is power. The more we understand about these fiery phenomena, the better prepared we'll be for whatever the sun throws our way.